today we consider another topic, that is oscillators. In this topic, we have to study what is feedback in amplifier and its type, how the electrical oscillations are produced by using tank circuit, then what are the essential conditions for transistor oscillator. Then we see the theory of feedback oscillators. Then some of the practically used oscillator circuits like Hartley oscillator, Colpitt's oscillator, crystal oscillator, and phase shift oscillator. Now, what do we mean by feedback in amplifier? In my previous lecture, we have seen what is the meaning of feedback. So what is feedback? Fraction of the output energy, either voltage or current, is given back to the input of the amplifier. Then we say that there exists a feedback. There are two types of feedbacks, as we have seen. Positive feedback, in which the input voltage and the output voltage are in phase. So the overall input voltage given to the amplifier increases due to the addition of the two voltages V in and Vf. Therefore, the gain of the amplifier increases. In negative feedback, we see that the input voltage and the output voltage, there is a phase difference of 180 degree. So the effective voltage appearing at the input of the amplifier is a subtraction of the two, V in and Vf. Therefore, the gain of the amplifier decreases. The positive feedback is used in oscillator circuits and negative feedback is used in amplifier circuit. So let us see in more details about the oscillators. Now firstly we see what is the difference between oscillator and an amplifier. So in this diagram, we have shown the block diagram of amplifier. So we see that in case of amplifier, we always give some input signal or weak input signal to this amplifier, and the amplifier increases the amplitude of this weak input signal, and that appears at the output in amplified manner. Here the output of amplitude of output signal is much more greater than the amplitude of the input signal given to the amplifier. And for working of this amplifier circuit, always we have to give the DC power. So here we observe that always in case of amplifier, there is an input signal and the amplifier produces the output signal, which is the exact replica of the input signal. Now let us see what is the block diagram of oscillator. So oscillator is an electronic circuit which converts this DC power into AC power. Here we see that there is no input signal given to the oscillator circuit, which is given in amplifier. But in oscillator, it does not require any input signal. Means simply it converts DC power given to the circuit into AC power. So the definition of oscillators is oscillator circuit converts DC energy into AC energy at very high frequency. It generates AC signal without requiring an input AC signal, which is required in amplifiers. Used in radio, TV, or dielectric and induction heating. These are the applications of oscillators. Now let us see how the oscillations are produced using a tank circuit. Now what is a tank circuit? So a tank circuit is nothing but parallel combination of a coil, and a capacitor. And what is the use of this tank circuit? A tank circuit produces electrical oscillations of any desired frequency known as oscillatory circuit or a tank circuit. So let us see the working of the tank circuit. Suppose initially we have charged this capacitor C by applying external DC battery. So some voltage is applied between the two terminals of capacitor by using a DC source. So what happens? The capacitor gets charged. The main important property of capacitor is that it stores the charges in the form of electrical energy. Now, consider a coil or inductor L connected across or between the two terminals of capacitor as shown in the figure through the switch S. Now, when I close the switch S, what will happen? The charged capacitor now start discharging through this coil, or the discharging current will flow through the coil. And due to this current, worsted effect, that is, the magnetic field will be produced around this coil. Means this electrical energy stored in capacitor is now converted into a magnetic field around the coil. As the time passes, this discharge currents will decrease, and when it becomes zero, what will happen? The magnetic field will collapse, and due to this there is a change in magnetic flux associated with the coil. And according to Faraday's law of electromagnetic induction, the induced EMF will be generated between the two ends of the coil, and this will again now send the charging current to the capacitor, or the capacitor now gets charged with opposite polarity because the direction of current according to Faraday-Lenz law is opposite in the previous case. Therefore, see here the polarities of the capacitor. The upper plates are positive, lower plates are negative when we connect a external DC battery across the capacitor. But when the capacitor discharges through the coil, this electrical energy stored in capacitor is converted into magnetic field. And when the current, after some time, the discharge current becomes zero, at that time, the magnetic field collapses. So there is a change in flux, and that it produces induced current or induced voltage according to Faraday-Lenz law, and it will charge the capacitor with opposite polarity. When the charging current stops, again the capacitor discharges through the coil. So this charging and discharging process of condenser continues, and as a result, the electrical oscillations are produced in this circuit. But the electrical oscillations produced in this tank circuit are damped oscillations, because here see on y-axis we have the current flowing through the capacitor. So during first cycle, the capacitor discharges or discharging current increases, it becomes zero. At that time, the magnetic field collapses and the current starts flowing in a reverse direction. Again, when this discharging current becomes zero, the charging again takes place. So this charging and discharging of capacitor gives rise to electrical oscillations. But what is the drawback of these oscillations? These are damped oscillations because the amplitude of oscillation slowly go on decreasing, and after a certain time they become zero when the total charge is lost by the capacitor. So these are damped oscillations. And the frequency of these oscillations is given by f is equal to 1 upon 2 pi root LC, where L is the value of self-inductance L measured in Henry, and C is the value of capacity of the condenser measured in Farad. So the frequency of these oscillations depends upon the values of inductance and capacity used in tank circuit. So remember here, these oscillations are damped oscillations because the amplitude of oscillation go on decreasing as time passes and the oscillations die out or vanishes.
If you like this video, don't forget to subscribe, comment and share this video with your friends. Thank you for watching.